Hello folks, I hope you're all doing good. This will be a bit different video from what I usually do on this channel, but I really hope you like it. Basically, for some time I wanted to do a video about Percona Everest. That is a open source database as a service platform running on Kubernetes. I really like it, well, first because it is based on database Kubernetes operators that I'm building here at Percona, right? But I also really like how simple it is and how with a couple of clicks or API calls, you can provision like full-blown, highly available database clusters and all of the necessary components to run it. But then I thought, why not call the tech lead of the project and like let him do the talking, right? And so this is exactly what we did. Let's hear from Diogo all about Percona Everest. So, hello, Diogo. How are you, man?
Hi, Enel. I'm doing great. Thanks for having me here.
Nice to have you, man. So, before we jump in, can you maybe introduce yourself to us, to all of the folks?
Yeah, sure. So, hi, I'm Diogo Recharte. I work at Percona. Currently, I'm working as an engineering lead for the Percona Everest project. And yeah, this is what we'll be talking in a bit about Percona Everest.
Okay. I'm excited to hear about it. Let's go.
Yeah. Okay. So first question, what is Percona Everest? Percona Everest is a free and open source platform, a cloud native one, specifically meant to manage databases. In general, it's meant to manage databases. It helps with the provisioning process, so a fully automated process to provision databases,
Hmm.
as well as the what we call the day two operations. So scaling your database as needed, performing backups, doing restores if you need to restore some data, and everything like that. And Percona Everest, being an open source project, is completely agnostic to the underlying Kubernetes distribution. So you're not locked
Hmm.
into any vendor. You don't need to run it into AWS EKS or Google Cloud GKE. You can run
Right.
it on-prem if you have your own self-hosted Kubernetes distribution.
Hmm.
So you're not locked into any vendor at all.
Nice. Excellent. Uh, can you maybe show us?
Yep. Yeah. Let's
Nice.
jump into what is exactly Percona Everest. So right now you're looking at the main dashboard for Percona Everest. Here you would see a list of databases that are running in your Kubernetes cluster. In here I have a MongoDB one, but let's go to how we would go about creating one. So
Hmm.
if you jump into the Create Database button, you'll first see that you can select to it which namespace the database gets provisioned to. Then
That
you
is
have a
a
selection
that is a
of three
Kubernetes.
different database types. Yeah,
Sorry,
that's Kubernetes
Kubernetes
namespaces.
namespace. Exactly. Okay.
Exactly. Then you have the three different technology types. You have MySQL, Mongo, and Postgres. And when selecting one of them, you can select which version of, in this case, Postgres you'll be deploying. You
Hmm.
can also select which storage class this database will use under the hood. So if you have different storage drivers provisioned in your Kubernetes cluster, you would have those options here.
Cool.
Then we can jump into the horizontal and vertical scaling of your cluster. You can choose how many nodes you want to deploy and what are the size of each node. So for this example, I can go with a 2-node Postgres cluster with a medium for CPUs and 8 gigabytes of memory, for example.
Hmm.
Then we can set backup schedules. So here we can use any S3 compatible API. In this case, I have an Amazon S3 instance setup. I can run daily backups at midnight, for example. I can
Hmm.
also enable point-in-time recovery for a more granular restoration process afterwards.
Right.
So pushing those write-ahead log files to the cloud.
Hmm.
And yeah, some advanced configurations. I'm going to skip over those. And you can also enable monitoring. In this case, I have here set up a Percona monitoring and management instance that you can use for monitoring, but we don't need that for now. So yeah, with a handful of clicks, you can get your Postgres database initializing. You can even jump into the details and see the components that are being provisioned, as well as the details of your cluster, the connection details.
Mhm.
So these would be how you would connect your application to the database by using
Right.
this host, the username and the password to connect to it. And yeah,
Cool.
within a few
Uh,
seconds, this should be ready to go.
can you just jump back for a second? So when you say components, can you go to components?
Mhm.
So that is basically Postgres nodes, Postgres database nodes, and PG Bouncer, right? So PG Bouncer is also created and up and running for you. So you will basically have a like in a couple of clicks, fully highly available like Postgres cluster. Nice,
Exactly. You don't need to manage all of these components individually. We handle all of that behind the scenes.
nice, 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 nice. Okay, okay, okay.
And yeah, and it's up and running. As you see, it was very quick to do. And
Nice,
I also
nice,
have
nice.
like I said, I have a MongoDB database prepared here for a quick demo of an application.
Mm-hmm.
And here I have a full stack application. This uses the MERN stack. So, and it's very simple. It's just to try to mimic what would be a company employee records. You can quickly come here and just, okay, let's create a new employee. I can create myself as a backend developer, for example, and add it to the list. I can delete it. And yeah, very straightforward, just a simple application that connects to the database.
Nice,
But I
nice.
want us to run through an example of a disaster recovery scenario. So
Mm-hmm.
let's say that this guy, this Bob Ross, which is our UI designer intern, we don't really want to keep working with him. We don't want to hire him. So we're going to delete it from the company records. But by mistake, I come here and I delete Chuck Norris, our full stack developer, our 10x developer that does everything for us. We
Are you
cannot
sure?
allow this.
Are you sure Chuck Norris is 10x? It's probably
Maybe not. Maybe
100x.
you're right. Maybe it's
Maybe
way
a
more
bit
than
more.
that.
Maybe a bit
It's
more.
hard to
Yeah.
put a number to it, right?
Exactly.
But yeah,
Yes,
the
yes, yes.
important thing is we need to get this guy back as soon as possible. So
Exactly,
we
exactly.
can come back to Percona Everest into our MongoDB database. And in the backups tab, I see that, hey, I have a very recent backup here. So I can, with just a few clicks, I can press restore to this database and I can select that backup. I could also use point-in-time recovery if I wanted to be more granular and go even up to a second of granularity and say, I want to restore the data back to that specific point in time.
Nice,
But in this
nice.
demo, we don't need that. So we can use the full backup and press the restore. By clicking the restore button, the database jumps into the restoring state.
Mm-hmm.
You can see that if you jump into the restores tab, you will have here the restore object that will be progressing and restoring the data. And
Okay.
obviously, this process depends, or the time that it takes will depend on the amount of data that you have in the database, as well as the performance of your nodes and everything like that. But
Right, right.
since we have a very small database, it's already done. You can see successful restore. If you jump into the databases, you also see that the database is up. So if I just jump back to our application and just refresh, hey, Chuck Norris is back. We just saved our company from disaster. As simple as that, just a handful of clicks.
Excellent, excellent. Really, really nice.
All right. So yeah, this is what I had for the demo, but I actually wanted to dive a bit deeper into what's
Mm-hmm.
the Everest architecture. So Everest in its essence is comprised of three main modules. So we have the front end, which is a
Mm-hmm.
React app. Then we have two components that run inside the Kubernetes cluster, which is the API server and the Everest operator.
Mm-hmm.
The API server is just a RESTful API written in Go that uses the Echo framework to expose the HTTP endpoints.
Mm-hmm.
And then we have the operator, which is a Kubernetes operator, a controller that manages some resources on Kubernetes. And to understand better how this works, let's mimic the scenario that we just demoed previously. So
Okay.
when I was creating the database, after clicking the Create Database button, the front end does an HTTP request to the API server. The API server will then take this request and translate it onto the language that Kubernetes understands, which is Kubernetes manifests.
Mm-hmm.
So we have one custom resource that we have several, but we have one custom resource for the database cluster. And the API server will convert that HTTP request onto a Kubernetes manifest of this type.
Mm-hmm. Okay.
Then this custom resource, the operator will take it and reconcile it to other resources for Kubernetes. In this case, it will leverage our existing Percona operators for the different technologies. So Percona operator for MySQL, for MongoDB, for Postgres.
Mm-hmm.
It will, depending on the type that you chose, it will reconcile it onto the specific custom resource that each of the operators understands.
Right,
And
right,
then
right.
these operators, as you know, do the heavy lifting under the hood to deploy all the components, all the Kubernetes components that need to be in place in order to spin up a database.
Yeah, yeah, exactly that. Uh, just like a shameless plug for all the folks that like want to understand a bit more about operators and custom resources. I have a whole video on this topic, so I will link it in the description so you can check it out if you want. Okay, sorry for the plug. Continue, please.
Yeah, no, but this is in general what is the architecture of Everest. These different components interface in this way, but these allow us to do one thing that it's a little bit harder with just the operators. This
Mm-hmm.
creates an abstraction, a more generic but also opinionated abstraction on top of what are the CRDs, the custom resources that we have for the individual database operators.
Right,
So
right.
by simplifying this interface, we allow every user without needing to have an in-depth Kubernetes knowledge to use this product and to just create a database, to manage a database without
Mm-hmm.
having to go into the nitty-gritty details about how Kubernetes works. It simplifies a lot the process.
Nice, nice, nice. So you basically, I guess, since you're exposing an HTTP API, right?
Mhm.
I guess you can call it directly and like provision your database, right?
Yeah, so these three components have their own interfaces, and you can use either one. So if you want to just use the UI to simply have a visual way of interfacing with this, you can. But if you have, for example, a CI/CD pipeline where you want to automate this process, you can
Mm-hmm.
use our HTTP API directly. So do the requests directly there
Right.
and provision your databases as you please. And also, if you are running some GitOps tools that already are a part of your Kubernetes environment, like Argo CD or Flux, and you
Mm-hmm.
don't want to use either the UI or the API, you can interface directly with the Everest operator by applying your Kubernetes manifest. So using
Okay,
these
okay.
GitOps tools, you can manage your whole infrastructure as code and still leverage the simplicity of Everest.
Excellent, excellent, excellent. And how do you test it? Like, I guess you test individual components, but I guess there are a lot of end-to-end tests to cover like all the flow from the click to like pods being created on the Kubernetes cluster.
Yeah, so we have different levels of testing. We obviously start with the basic unit tests for each piece of code or functions
Mm-hmm,
that
mm-hmm.
we have. But then we have these more like integration and end-to-end tests. We start from the operator side when we use a framework called Cuttle. This framework allows you to deploy some manifests to a Kubernetes cluster and also specify which manifests you are expecting to get out of that after the reconciliation happens. So we do those end-to-end tests directly in the operator to see, hey, I applied this manifest and I get these other manifests in these states, and this allows us to know if all the components are being deployed correctly. Then we
Mm-hmm.
also have API tests, integration tests at the API server level. So basically testing the interaction of the API by doing the request and then checking if also the everything got deployed correctly. We use
Okay.
Playwright, the Playwright framework for this. And we also use Playwright for our full-blown end-to-end tests from the UI side. So
Aha, okay, okay.
we also have tests where you just go through the UI, click a button, or the tests click the buttons for you,
Right.
obviously, and
Mm-hmm.
check the full end-to-end path that the user would see if they were using the UI. So we have those as well. So a full test suite from each component is available.
Nice, nice, nice. Uh, this is GA, right? So it is like a production ready product.
Yeah. So actually, I can jump quickly to our GitHub page, which, by the way, if anyone wants to have a look at the project, you can search for it here, Percona
Mm-hmm.
organization as Everest repo. And yeah, you can see here that you are currently at the release version 1.2. And since version 1.0, we have been generally available. So the main functions that I showed you here, they are all production ready.
Nice, nice.
Obviously,
Okay.
with each release that we do, we add some new features, and sometimes these features we release them as tech previews. For example, right now in this version 1.2, we released the role-based access control feature,
Okay, nice.
which is currently in tech preview. So this feature we don't advertise as production ready
Right,
just
right,
yet,
right.
but we
Mm-hmm.
clearly state this in the release notes and stuff. And yeah, these type of things it's great for us to be able to push stuff early to get the community feedback
Mm-hmm.
and test stuff out.
Nice, 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 nice. Uh, where can folks like learn more about the Everest? Like, of course, we have a GitHub repo.
Yeah, we have the GitHub repo. We also have here the link to our documentation. We have a very thorough documentation about how to install, how to manage the different components of Everest and everything. So this would be your starting point
Right,
to get to
right.
know about Everest. But obviously, if you have any questions, any issues, just open a GitHub issue, get in contact with us. We also sometimes run discussions here on GitHub to get feedback from people for specific features. So
Mm-hmm.
yeah, I encourage everyone to just jump in, try it out, give us your thoughts, and we will definitely take into consideration any feedback that we hear.
Nice, nice, nice. And not just that, I guess they can open a pull request as well, right?
Yeah, of course. We are
Exactly.
fully open source from the smallest UI component until the deepest Kubernetes controller. So if people just want to contribute, they are free to.
Nice, 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 man. Okay, so this was pretty insightful to me as well. So anything else maybe to add, to share?
No, just wanted to highlight that, yeah, Everest tries to to be a platform that allows every type of user to jump in. So if you
Cool.
have one team and you're a platform engineer that wants to have all of your different teams, give them access to create and share databases, for example, you can specify separate namespaces for each team. You can allow or give a restriction in terms of permissions to each
Mm-hmm,
user.
mm-hmm.
And people that usually would not have the necessary knowledge to spin up a database, they can easily do that. But if you're also an experienced database administrator and just want to run your full production database on Kubernetes, then Percona Everest also makes it much easier for you to manage all of these. So this covers some different use cases, but they can all be managed within Everest. So again, shout out for people to just try it out.
Cool, cool, cool. Like you already mentioned, all of the database operators that are running behind the scenes, right? You can use them on their own, but like this simplifies the whole thing a lot more, right? So even
Yeah,
though operators are really like it is, you apply a YAML and you have a full-blown, highly available MySQL cluster, you still need to be a bit more knowledgeable about at least Kubernetes, right?
Yeah,
So
yeah, you still
this
need
is
to
like,
babysit your cluster a little bit, yes.
yeah, exactly. Cool. Okay, man. This was really nice. This was really helpful to me as well, right? Even though I'm pretty familiar with the product, and I don't know. Thank you a lot.
Yeah, thank you. Thank you for having me. It was a pleasure. See you around. Bye.
Bye. All right, guys. This is all for today. I really hope you liked the video. I really hope this was useful for you. And also, I hope you like this format of a video. This was like something new for me. So if you liked it, we can do something similar in the future for sure. And as usual, if you like the video, maybe give me a thumbs up and consider subscribing so you don't miss something similar in the future. Thank you very much one more time and see you in the next one. Bye-bye.